Hi everyone, this is Jay, your tutor for computer networks. In the last session, we have discussed what is OSI model. We have seen the responsibility of each layer in brief. In this session, we are going to see the difference between OSI and TCPIP. Firstly, we will see what is OSI and what is TCPIP separately, and after that, we will compare them. So let's start. So the OSI model was introduced by International Organization for Standardization in the year 1984. OSI stands for Open System Interconnection, and it is more like a theoretical model. So if you want to make a device that can communicate over the internet, then you should follow the OSI model. The OSI model is not a protocol because in the OSI model there are no protocols available that you can take directly and implement. It is just for reference only. And as you know, the OSI model has 7 layers and each layer has different functionalities. And these 7 layers work together to send and receive data. And the OSI model is a reference model. You cannot implement this model directly. It is just for reference. So let's see the working of OSI model. As you can see on the screen, this device wants to send data. So when the device sends data, data will pass from all the layers. You can see there is OSI model. So the top layer of the OSI model is the application layer. After that, presentation, session, transport, network, data link, and the physical layer. So when device send any data, the data will pass from application layer to the physical layer. Means flow of the data is from top layer to bottom layer. So for example, suppose you have open and chat application and you have write a message to your friend and you press the enter. So when you press the enter, the data will be entered to the application layer. You can see the data that you have typed is D7, but the application layer has added some data to the original data, which is H7. And after this H7 and D7 will be passed to presentation layer, it will be encapsulated and header H6 will be added. So what is this header? Each and every layer will add header and it contains some extra information which can be understood by that particular layer only. So when H7 is added by the application layer, no other layer can understand the meaning of that H7. And after that, H7 and D7 will combine and it will become D6, and at the presentation layer, H6 will be added. Then after H6 and D6 will be passed to the session layer. There it will become D5 and session layer will add H5, which is header for session layer. After that, H5 and D5 will be encapsulated at the transport layer. So H5 and D5 will become D4, and in the transport layer, H4 header will be added. In the network layer, H3 will be added. In the data link layer, header and tailor will be added. And in the physical layer, all the data will be converted into bits. So it will be converted into signals and it will be sent to the destination. Then after, at the receiver side, when the receiver receives data, the flow of the data will be from bottom layer to top layer. So you can see that again there is a OSI layer, and the difference is that the flow of the data is changed. So when the sender is sending data, flow of the data is from the top layer to bottom layer. But when the receiver is receiving data, the flow of the data is from the bottom layer to top layer. So you can see at the physical layer, the data means the signal is received. So when this data is passed to the data link layer, the header will be removed by the physical layer. Notice the header that is being added at the sender side at the physical layer, that header will be removed at physical layer only. Now it is passed to data link layer, header is removed at physical layer and it is passed to the data link layer. In the data link layer, header and trailer will be removed and D2 will be delivered to upper layer, that is the network layer. In the network layer, header H3 will be removed and D3 will be passed to the transport layer. At the transport layer, H4 will be removed and D4 will be passed to the session layer. So as the data is passed, it will be, the header will be removed at each and every layer, and after that data will be delivered. So you can see the header is removed at particular layer only where it was added at the sender side. Now what is TCP/IP? The TCP/IP, it is called Transmission Control Protocol or Internet Protocol. It was developed by Department of Defense. So in the TCP/IP protocol, there it is a set of protocols, and in TCP/IP there are many protocols available. For example, there is a transmission control protocol, there is a user datagram protocol, address resolution protocol, DNS, HTTP, ICMP, and many more. And the TCP/IP has 4 layers: the application layer, transport layer, internet layer, and the network access layer. So what is the main difference between the TCP/IP and the OSI model? The main difference between the TCP/IP and the OSI model is that the OSI model is the reference model, but the TCP/IP model is the actual implementation of the OSI model. So the internet right now is running on the TCP/IP protocol. So there are, in the TCP/IP there are set of protocols available, and user can take any protocol from the TCP/IP and he can implement that protocol to its own system, right? So this is the 4 layers for the TCP/IP. The top layer is the application layer. After that there is transport layer, then internet layer, and the network access layer. So when sender sends data, the flow of the data will be from application layer to network access layer. And when the receiver is receiving data, the flow of the data will be from the network access layer to the application layer, means bottom to top. Let's compare the TCP/IP and the OSI. So you can see in the OSI model there are 7 layers that you know: the physical layer, data link layer, network layer, transport layer, session, presentation, and the application layer. The TCP/IP model has 4 layers: application layer, transport layer, internet layer, and the network access layer. So you can say that in the OSI model, the data link layer and the physical layer are combined together and it will be called network access layer in the TCP/IP. So the functionality of the data link layer and the physical layer are included in the network access layer. The network layer is called internet layer in the TCP/IP. Transport layer remains same as the transport layer, and the application layer, presentation layer, and the session layer are combined together and it will become application layer in the TCP/IP. I have just said that in the TCP/IP model, each layer will have lots of protocols and user can select one protocol from many. So let's see how many protocols are there. So let's see the different protocols for TCP/IP model. In the application layer, there are different protocols such as HTTP, SMTP, Telnet, FTP, DNS, RIP, and SNMP. In the transport layer, it contains mainly 2 protocols, which is TCP and UDP. TCP means Transmission Control Protocol and UDP means User Datagram Protocol. TCP is more secure as compared to UDP. In the internet layer, there are many protocols available such as ARP, IP, IGMP, and ICMP. ARP means Address Resolution Protocol and it binds MAC address with the IP address. The IP protocol specifies the IP addressing. So there are two type of IP address, the IPv4 and IPv6. IPv4 is of 32-bit and the IPv6 is of 128-bit. The range of the IPv4 means total number of IPv4 is 2 raised to 32 and total number of IPv6 is 2 raised to 128. The IGMP and the ICMP are for error reporting protocols. The network access layer has different protocols such as Ethernet, token ring, ATM and frame relay. So what is the meaning of network access layer? In the network access layer, the protocols, for example, the Ethernet specifies that which type of topology you should use or which type of cables you should use so that you can make the network very efficient. So there are different protocols, Ethernet, Telnet, ATM, these all protocols tells the same thing, right? Now let's compare the OSI and the TCP/IP. You can see the transmission control protocol and internet protocol is TCP/IP and the open system interconnection is the OSI model. The TCP/IP is a client server model and the OSI model is a theoretical. Means the TCP/IP is the practical implementation but the OSI model is not practically implemented. It is just a reference model. The TCP/IP model has 4 layers. The OSI model has 7 layers. The TCP/IP was developed by Department of Defense. The OSI was developed by ISO. The TCP/IP model is tangible, but OSI is not. TCP/IP is widely used, and OSI is not used because it is a theoretical concept. And it is a the TCP/IP is a horizontal approach, and the OSI is a vertical approach. So this is it for today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.